This is lesson 3.5, area of a triangle. Before you begin watching the video, please make sure that you have a sheet of graph paper and a straight edge or a ruler. Please make sure that you also write down every note as I write it down in the video too. Remember to pause the video at any time if I'm going too fast or you need to catch up, or if a certain concept wasn't clear. Now, the title for this will be 3.5, area of a triangle. So make sure that you use your ruler to underline the title. Now, as you recall from last day, or last lesson 3.4, the area of a parallelogram formula, and I'm just going to jot it down here as a reference, is base times height. Now remember, in this case, instead of using length times width, we're using new terminology so that we're consistent. We're going to call it base times height. A equals B times H, or A equals BH. Okay, so I'm just going to take my ruler and also box this out too, so that, oops, okay, my ruler tool is not working with me. There we go. Okay, so that it's distinct from the rest of the page. So make sure that you do the same. Now the reason why we mentioned the area of a parallelogram formula is because the area of a triangle is closely related. You may recall in previous lessons or from the Brain Pop video of area of polygons, a triangle is half of a parallelogram. So I would like you to demonstrate that by using your grid paper as I use it on the video here. So I'm just going to extend the page here, and please draw this triangle exactly using the grid paper as I'm doing it here. Now remember, I'm working with centimeter grid paper on the video. You may not necessarily have centimeter grid paper, so just be mindful of that. I would suggest counting the same number of squares and representing each square as a centimeter, so you're just going to have to do it or use a scale on the side there. So what I've done here is I've drawn a triangle, and the base here covers 4 centimeters squared. Therefore, I'm going to label the base as being 4 centimeters here. Okay, now the height I'm going to draw, and as you recall, the height, as in the case of a parallelogram, with the triangle, it's the perpendicular distance from the base to the opposite side. So remember, we draw the height reaching the highest point of the polygon like that. We also indicate it with a square corner like that. The height in this case is 7 centimeters. So again, draw this triangle as exactly as you possibly can on your page. And again, if you need to stop the recording or pause it to catch up, please feel free to do so. Remember, I said earlier that a triangle is half a parallelogram. Okay, now if we were to just multiply the base and the height here, we'd have 4 times 7, we would get 28 centimeters squared. But that clearly is not the area of the triangle here. Now, you don't have to draw this part, but I just want to show you here what happens if we actually extend this. And this is where you can see that a triangle is half a parallelogram. Oops, and that's not what I want. Okay. Maybe I'll just use the green line here like this. Okay. If I extend it like this, now pretend that this green line here is like that. Now again, you don't have to draw this, but can you see now that this height here is also 7 centimeters, right? Okay. and the base here still remains 4. So actually, this rectangle or parallelogram is 28 centimeters squared. Okay, so again, you don't have to draw this, but this is just demonstrating that the rectangle or parallelogram here is 28 centimeters squared, but it's not the triangle. Okay, the triangle is half the parallelogram. And remember that a rectangle is a type of parallelogram. So I'm actually going to undo all of this. So hopefully I didn't confuse you too much there. Okay, now this is the formula you need to know for the area of a triangle. So the area of a triangle is actually the base times height divided by 2. Now, there's a short form of doing this, and this is the following. And this is actually the one I'd like for you to memorize. Area of a triangle is base times the height divided by 2. Remember, this symbol means divided by because we're writing it like a fraction, but we're calculating the base times the height and we're dividing the answer by 2. Remember, with any substitution, you need to show your substitution in brackets. The base in this case is 4 centimeters. The height in this case is 7 centimeters. Okay, and we're going to divide that by 2. Now, the answer to 4 times 7 is 28 centimeters divided by 2. Then our final answer is 14 centimeters squared. We circle our final answer. Okay, now as we did in the previous lesson, area of a parallelogram, we're going to check our answer using the grid paper and using the triangle we just drew. So in one color, I'm going to choose green. I'm going to count the number of full squares. We have 1 full square, we have 2 full squares, we have 3 full squares, 4 full squares, 5 full squares, 6 full squares. So it looks like we've got about 6 full squares. So it looks like we've got 1, 2, 3, 4, 5, 6. I'm actually going to move that count up to 7 because it looks like this bottom one here is almost full, is actually quite full, so we'll count that as a full square. So far, we have 7 full squares. So remember, this is an estimate. We may not exactly get 14 in this case, but we'll probably get quite close. In another color, blue, then I'm going to count the squares that are almost full, and we'll count those as full squares. So squares that are almost full, we've got 1 that's almost full, we've got 2 that's almost full, and 3 that's almost full, I would say. Doesn't look like there's anything else that's almost full. So then we have 3 also full squares. They're almost full, so we count them as full squares. Next, in yellow, we're going to count the squares that are half. Okay, so this one is probably more 3/4, but we will count that as a half. So we'll do, that's a half, that's another half, that's another half there, that's another half there, that's another half there. So far we've got that. Okay, that's a little bit bigger than these 3, so we'll count that one there too. And maybe this one here too. Now that's a little less than half. So how many halves do we have? 1, 2, 3, 4, 5, 6, 7. So we've got 7 half squares. So the 7 half squares divided by 2 would actually give you 3.5 full squares. So if we added our totals here in our estimate, we would have 7 full squares plus another 3 full squares plus 3.5, and we would actually get 13.5 square centimeters as our estimate. Now, looking at the top here, we could maybe add in these quarter squares to get another half square, so we'd get 14, but we're pretty close to what we actually came up with in our calculation. Now, applying the formula for an area of a triangle, we're going to go to your textbook, and this is page 114, lesson 3.5 in your textbook. We're going to look at question 10, and again, I'll do that on a separate sheet of graph paper, so you should do the same. The question says, Daniel wants to plant as many daffodils as he can in a triangular garden. He finds out that he should plant no more than 49 daffodils for each square meter of garden. How many daffodils can he plant in his garden? So in the diagram here, we have the height as... Okay, so what we're going to do is we're going to do question 10, and remember that in your textbook, we're looking at page 114. I just had to re-record another part of this lesson, so it may seem a little bit disjointed. I'm going to get another sheet of graph paper up here, and we are working out of 3.5 in your textbook page 114. Okay, and we are working on question 10. So we're going to recreate the diagram of the triangular garden, and it's not going to be to scale, which is okay. Okay, and then I will indicate again the perpendicular height, which is from the base, the perpendicular height from the base to the opposite side. We always indicate that with a right angle there. Going back and referring to the question, let's see here. The base is 2 meters, the height is 1.6 meters. Base is 2, the height is 1.6. Okay. And it's 1.6 meters this way. Okay, remember that we need to apply first or write down the area formula for the area of a triangle. You always write this down first. It is base times height divided by 2. You could also do b times h divided by 2. It's up to you as to how you want to do it, okay? In this case, you always show your substitution. The base is 2 meters times the height is 1.6 meters divided by 2. Now, one thing I forgot to mention too, and I may not have done this in the previous example, is the initial calculation is already in meters squared. So when you're calculating 2 meters times 1.6 meters, it should actually be in meters squared, and then you divide it by 2. So it's 2 times 1.6 will give you 3.2 meters squared. Now we're not finished yet, so we still recopy the steps we haven't done in the calculation. We do 3.2 meters squared divided by 2, and we get 1.6. Whoops, 1.6 meters squared. So that's the area of the triangle. Now, remember the question asks though, asks that how many daffodils can he plant in his garden if he can only plant no more than 49 daffodils for each square meter of garden. So going back to the question here. So we know that he can only do 49 daffodils per square meter. So in this case, we're going to do the calculation 49 times 1.6 meters squared. So what we end up with is 49 should be 78.4. So approximately, we always want to round to the nearest whole number because you can't have a partial daffodil, so he can plant 78 daffodils in his garden. And that is the area of a triangle.